Hello, this is Mrs. Allison. Today we are going to learn how to solve quadratics using square roots. So far we've talked about solving quadratics by factoring. That's what we spent a big chunk of last week doing. And today we're going to talk about solving quadratics using square roots. But this is a much more specific type of solving. We, of course, could still factor this, and we're going to look at this problem done several different ways. So, how do you know when to use square roots to solve, or when it is okay to do so? And the way we know that is if we have only one square term. So if we only have the square term, we don't have a bx term, we just have something that is squared, that is when we are going to solve using square roots, unless the directions tell us to. So the first thing that we're going to do is check to see if we only have a square term. Then what we're going to do is we're going to get our x squared term alone. So if x squared has the 4 on the same side as it, this one does not. Oops, I have a different pointer than I want. This one does not. See how the x squared is by itself, whereas over here on the right-hand side of the screen, the x squared is with the -4. We want to get the x squared term alone. And then what we're going to do is we're going to undo the square. And the way that we undo the square is by taking the square root. Square and square root are inverses of each other, just like addition undoes subtraction or multiplication undoes division. The square root undoes something that is squared. Okay, so you might be thinking, oh, well, this is pretty easy. So I am going to take the square root of both sides. So I have x squared equals 4. And if I take the square root of both sides, if square undoes square root, then the left-hand side is just x. I'm going to make that pencil mark just a little bit bigger. And the right-hand side is just 2, you might think. Perfect. Well, we have our answer. But is that the answer? I know that 2 squared, if I were to check my work, and I were to come back here and I were to check this, I know that 2 squared does equal 4. That's true. But is there anything else that could equal 4 when squared? What about -2? What if I were to use -2 and square it? Wouldn't it also give me 4? Why is that? So let's make a note. What I know is that my answer is both x equals +2 and x equals -2. You will often see the answer written this way, x equals this little plus and minus sign on top of each other, so plus or minus the square root of 2. So that's red, x equals plus or minus the square root of 2. So both +2 and -2. This is our answer, but why? Okay, we need to know why. So let's look at several different things. Let's first look at this problem by factoring. This should be review from what we did last week. Okay, if I'm going to solve by factoring, remember the first thing I need to do is I need to get it equal to 0. So 0 equals x squared minus 4. Okay, and if I'm going to solve this by factoring, what I'm going to do now is I'm going to factor, and I should notice that x squared minus 4, if I look at the diamond, means I'm looking for 2 numbers that multiply to -4 that add to 0 because there is no x term. And when I get those, I get a -2 and a +2. That's a -2. A -2 and a +2. So when I factor this, I have 0 equals x plus 2 and x minus 2. Now if I use the zero product property, The zero product property tells me to have x plus 2 equal to 0 and x minus 2 equal to 0. And then I would subtract 2, and I get x equals positive 2. And I would add 2, and I get x equals, oopsies, this was supposed to be negative 2 over here, and x equals positive 2, which is where we get x equals plus or minus 2. Great. That's solving by factoring. So if you need to pause this for a moment, because I'm about to erase some of this, to write it down, that'd be great. So pause the video. If not, I'm going to erase this, and I'm going to come back and show you another way that we can solve this. And we haven't talked about this method just yet, but I want to look at it with you today. And that method that I want to talk to you about is by graphing. So I am going to look at how I can solve something by graphing and how all of these pieces work together. So to solve by graphing, I know this graph is in standard form. So the first thing I'm going to do is I am going to find my axis of symmetry. And remember, we find our axis of symmetry by doing the equation x equals the opposite of b over 2a. Okay, in this problem, I don't have a b value, so x equals the opposite of 0, which is just 0, over 2 times a, which means x equals 0, because 0 divided by anything is just 0. And then I would go back in and plug in my axis of symmetry to find my vertex. Remember, my vertex is the ordered pair 0, and then whatever I get when I plug in 0. So I'm going to plug 0 in, y equals 0 squared minus 4, which means y equals negative 4. Okay, if I look at a graph of this right now, okay, I have a vertex, I have an axis of symmetry at 0. I have a vertex right down here at negative 4, 0, negative 4, and I need my next points. So I would look at my next points. Well, if I plug in 1, okay, if I plug in 1 or negative 1, I get 1 squared minus 4, which gives me negative 3. Well, negative 3 is right here, and I can mirror image it. Now that would be enough to graph it. It's not enough to solve by graphing, and we'll spend more time on this, but I want you to see how they're all related. So the next thing I would do is plug in my next point. Let's try 2. If I plug in 2 squared minus 4, I get 0. So at 2 and negative 2, I have values at 0. Okay, so now I have this nice pretty graph that I can sketch, but let's talk about how we know where our solutions are. Well, we already know from before when we solved using square roots that our solutions are x equals plus or minus 2. Here is what I want you to look at for a moment. Look at this. What is this value right here? That's negative 2. What is this value right here, this x value right here? That's positive 2. We can see my x-intercepts are the same as my solutions. X-intercepts are solutions. So I can check my work by either factoring or graphing. Now, do I want to do that every time? No, I don't. So I know that if I have to take the square root, so if you have to take the square root, and I'm going to abbreviate, meaning it wasn't already part of the problem, you had to write it in to solve, then your answer is always going to be plus or minus whatever you get. Okay, let's go on to the next problem. Okay, so let's look at this problem. This says x squared equals 36. So remember, I can choose to solve by square roots because I only have an x squared term. I don't have another x term. So to solve this, I am going to take the square root of both sides, because that's how I want to undo something that's squared. The square root of something squared is just itself, so this is just x equals. Now, because I had to physically take the square root, my answer is going to be plus or minus 6. Both values work. Why? Well, if I want to check my work on this, both values work because positive 6 squared is 36 and negative 6 squared is 36. Both values give me or make the equation true. Okay, so how do you think I do the problem over here when it's 2x squared equals 98 over on the right? I need to get that x squared term by itself. So I am going to divide both sides by 2 to get the x squared term by itself, and that gives me x squared equals 49. And then I need to undo the squared, so I'm going to do the square root, and that leaves me with x equals, remember I physically wrote in the square root to solve this problem, so my answer is plus or minus 7. How do we do? Okay, so let's make it a little more fun. All right, I told you I was going to make it more fun, which you know by now means it's just going to be a little bit more complicated. So let's look at this next problem. All right, on the left, we have the problem x minus 3 quantity squared equals 16. It doesn't look exactly like the last problem because there's a set of parentheses, but do you notice how I only see one squared term? I have this whole something squared. Something squared equals 16. Well, that's the perfect recipe to be able to solve by square roots. So let's erase that. And let's go and solve using square roots. So using square roots, my first thing is to get the squared term alone. Well, it is. So the next thing that I'm going to do is I'm going to undo the squared term. Okay, I'm going to undo the squared term, and what that leaves me with is x minus 3 equals, now remember, I took the square root, so my answer is plus or minus 4. All right, well, your first thought may be, I could just add this 3 over to both sides and I would get plus or minus 7. Well, guess what? That would be wrong. We don't want to do that, so let's look at what we can do. Do you agree with me that this is really I didn't want that color. Did you agree with me that this is really two different equations? X minus 3 equals positive 4 and x minus 3 equals negative 4. I have two different equations, kind of like we do when we set up our zero product property. Two equations. One says x minus 3 equals positive 4. One says x minus 3 equals negative 4. And then I go through and solve each equation. So I'm going to add 3. So I get x equals 7. And I'm going to add 3 to this left-hand one, which gives me x equals negative 1. Now, I want to check my work. Let's check to see that these two values, x equals 7 and x equals negative 1, both work. So let's check. We'll first do the x equals 7. And if I plug in 7 for x, I get 7 minus 3 quantity squared equals 16. And remember, order of operations would tell me to do what's in the parentheses first. So that would give me 4 squared equals 16. And what is 4 squared? Yeah, it's 16. So 16 equals 16. So 7 makes the statement true. Let's check negative 1. Is negative 1 minus 3 squared equal to 16? Well, let's do what's in the parentheses. Negative 1 minus 3 gives me negative 4. squared. And what do I know about negative 4 squared? That's right, it is 16. So we know that these two answers are our solutions. If we were to graph this, where would we see these two values, these two x values, x equals 7 and x equals negative 1? That's right. These are our solutions, or another name for them is x-intercepts. Okay? All those two phrases can be used interchangeably. In fact, we're going to introduce two other words that could happen that go along with this as well in the next lesson. So let's try the problem on the right over here. All right. Is the squared term by itself? Yes. Okay, so what I'm going to do now is I am going to take the square root of both sides. So I have x plus 1 squared equals 25, and I am going to write in the square root, meaning I have to physically put it in there to try to solve this. So we get x plus 1 because the square root undoes the square, and it leaves me with just the x plus 1, equals, and remember, I took the square root, so my answer is plus or minus the square root of 25 we know is 5. So I have two equations. I have the equation x plus 1 equals positive 5, and I have the equation x plus 1 equals negative 5. All right, so I'm going to do my algebra, and I get x equals positive 4, and I'm going to subtract, oopsies, 1 over here, and I get x equals negative 6. So my two solutions, or x-intercepts, if I were to graph this, would be 4 and negative 6. All right, if you need to, go back and rewatch this video a little bit. See if it will help you clarify some of your questions on solving by square roots. And then we're going to move on to another type of solving.